Okay, hello everyone. It's about 10 o'clock, so I think we should get started here. Just to start, my name is William Matchin. This workshop started after CUNY 2020 at UMass Amherst had to be unfortunately canceled due to the coronavirus pandemic that was occurring, but they very fortunately for all of us, I think many of you attended CUNY, they transitioned the conference to a virtual conference using Zoom. And it was actually, I think, fantastic. And just thanks to all the organizers for getting that going in such a short time. And it was really surprisingly good. And one of the things that was good about it was that it allowed junior scientists who benefit greatly from having these presentations to put on their CV and network, at least allow them to get some of that opportunity. But one of the things that came up during the conference, just in talking informally to attendees, was a concern about data collection and the opportunities for data collection that, of course, are extremely problematic or mostly halted right now due to the pandemic and the social distancing that everyone is doing. And so there was a lot of interest in doing, here, sorry, I put my dog down, he's being a little distracting here. There's a lot of interest in getting remote or online data collection going. And I think it's actually quite fortunate that we're at this part of our careers right now, because there's actually a lot of tools available that people have been using for some time in linguistics and psycholinguistics. So I think that this actually is a good opportunity for us to learn about them and become familiar with it, and basically, start using those tools as much as we can to get that going. So at any rate, so for today, this is the schedule that I was able to cobble together. Again, just to let you all know, this basically was cobbled together in the last 2 days. So, I'm extremely grateful to everyone who reached out to me, who offered to help or to present. Also, thank you so much to you guys for showing up and basically helping to make this worthwhile workshop. So basically what we'll be doing is we'll be starting the presentation with, I hope that Shohini Bhattasali is here. Shohini, if you're here, can you please chat me just to make sure that we're on schedule for today. And so Shohini is a researcher at the University of Maryland, and she has been doing this interesting work in neuroimaging. And one of the things that is very difficult right now for all of us that do neuroimaging. So, I am a cognitive neuroscientist. I study language in the brain, and I use typically fMRI, lesion symptom mapping, and aphasia. And right now, of course, even with the remote tools that we're going to be discussing, it's going to be, essentially still impossible to collect neuroimaging data. So one thing that we wanted to make sure to add was the opportunity for basically to access publicly available data sets. And fortunately, again, like I said, there's a lot of this is becoming more and more available. And so Shahini has been doing some very interesting work, and they've posted their data sets online. So her presentation will focus on discussing those data sets, basically what they are. They're both in fMRI and EEG, and how to access them and understand the data. And then following that, we're going to have a nice long, almost 2-hour workshop by Noah Nelson and his colleagues at Finding Five. So again, I do neuroimaging. I'm not really familiar with any of these tools. So it's actually one of the great opportunities of organizing workshops is you can organize it by not knowing anything yourself about what you're organizing, but getting other people that do know what they're doing to come and teach you. So Noah has been working on Finding Five, which is this really great platform for online linguistic and psycholinguistic experiments. And they've got a lot of nice features, and they focused a lot on making this tool accessible and easy for those of us that are not as savvy with programming or familiar with the tools to get them up and running quickly, and integrate that with Amazon Mechanical Turk, which I'm sure Noah will talk about in detail. So that's going to be a great workshop. It's going to be almost 2 hours, and it's going to be hands-on. So you'll have an opportunity to access their system and try to get your own experiment up and running. And so while that's happening, if you need help Feel free to use this Q&A document. I posted at the beginning of a chat links to 3 documents online that you can edit. One is a Google document for Q&A. So basically, if you have any kind of just question, I'm going to keep you all muted. And then what I'm going to do is basically go to the question document and have some wonderful volunteers that offered to help. That's Nick Huang at UConn, Gwen Rarig at UC Davis. And I also got some help from Lena Karlovskaya and Jennifer Arnold, who offered to sort of monitor the Q&A document. And basically what we'll do is we'll look at the Q&A document. We see questions. When the appropriate time comes, we'll basically unmute you so that you can ask your question and get that response. If you want to have a more private video chat, and that might be particularly helpful for the Finding 5 tutorial, you can go to that Excel spreadsheet. It's this open Zoom meeting spreadsheet. In that first tab, Monday Virtual Workshop, basically you can just put your name and put a link to a Zoom meeting or something like Skype. Oh yeah, okay, so someone just asked if I can post the documents again. I'm gonna send those in the chat right now. So let's see. And please bear with me because I'm still getting used to Zoom myself. By the way, Zoom is really fantastic for meetings. Like Skype, I've been using Skype for all this time, and they're really Skype is awful. Zoom is great, so it's really a great resource. At any rate, so this Excel spreadsheet, the Zoom meeting signups, just go ahead and put your name, put a link to a Zoom meeting or a Skype meeting or any other kind of. Oh, interesting. Okay. Maximum participants. Does anyone know how to add more participants? I didn't realize that there was some kind of limit to the number of people that can join. If anyone knows how to add more than 100, could you add to that chat? If you know people that are trying to get in, oh, this is 1,000. Well, I just noticed that on the Google Sheets, someone, I have to create, okay, wow, well, that's crazy. Okay, so apparently I have to pay more money to get more than 100 people. So consider yourselves the lucky ones who are able to log in. And I think I've got our presenters all logged in for this first session, so that's good. But this will all be recorded and posted later. Okay, so if you weren't able to make it, sorry to you, people that are listening in the future, but we had you in mind at this moment in our lives. Okay, so yeah, so like I said, we'll do the Finding 5 workshop. You'll be able to log into their system and get an experiment up and running. And like I said, if you want some one-on-one help, feel free to post a link to your chat, so that way we can get someone to come and talk to you and give you any help that you might need. And then there's one more link to resources. That's the third document that I sent out. Basically, this is just a link to all the materials that we discussed. So it's just a list of things that you can find online. And if you have anything to add, please feel free to add to that and edit that document. That's not a problem at all. I just wanted this to be a resource that's available to all of you that you can just communicate with each other and share any resources that you might have or experience that you're willing to share. So then we're going to have lunch around 12:15, 12:45. This is mostly just to give you guys a break and kind of tune out for a little bit. And then at 12:45, we're going to come back with a short presentation by Florian Schwartz. And he's going to talk about PC-IBEX, which is a sort of alternative to Finding 5. It's very similar from what I've been told in terms of how to use it, the programming language that's involved. But I think it offers a lot of other customizable features. In particular, he mentioned there's a kind of beta version of online eye tracking using webcams. And I was particularly interested in that because that hasn't been developed as much as other methods. So that could be interesting. And then we'll have some discussion by Bree Stark and Joshua, I forgot his last name. But basically, they'll be talking about some online databases for neuroimaging data, as well as data from atypical populations, particularly aphasia, traumatic brain injury, and dementia. So for those of us that do work in those areas, there's actually these great publicly available or sort of semi-publicly available data sets for you to do work in aphasia. Let's see. Yeah, and then following that, we're just going to have a short panel discussion. And the idea with that panel discussion, let's see if I can go to my presentation here. Yeah, the idea of the panel was simply to point out that a lot of things that might be very useful for us right now in the short term is just getting data from another person that you may know or not know, but maybe there's data that's published, but they haven't publicly released it. It's still, a lot of researchers are perfectly happy to share that data with you. So we just wanted to discuss a little bit about how to navigate that. And so Bree Stark has also done that a few times already. And so she's going to be discussing some of that. And if I've got some other people too that can jump in here and discuss their experiences with just getting data from people that could be helpful. Okay, with that said, I'd like to turn over to Shohini. And so what I'm going to do is I am going to end the show, and I am going to, okay, great. You've already got that going. I think I need to unmute you. So let's see. Okay, are you unmuted, Shohini? No, you are not. Okay, I will unmute you. Okay, you should be unmuted.
Yeah. Hi, okay. Can everyone see my screen?
Yeah, if you can't see this, I can see your screen fine, so I assume that that will work for everyone.
Okay, so yeah, so today I'm going to be talking about the ALICE datasets. These are, we just want to point out, so these are two kind of newly released datasets that, you can use if you're right now working from home or unable to collect any kind of new data for your experiments. So these are two parallel naturalistic EEG and fMRI data sets, and it's based on chapter 1 of Alice's Adventure in Wonderland. So as you can see in the figure, so all the participants heard the same chapter. So we have the time point of every word in the story, and depending on the modality, fMRI or EEG, we measured bold signals or the electrophysiological signal. And overall, in this chapter, there were 2,129 words and 84 sentences, which are on an average 25-ish words long. And so overall, the stimuli is about 12 and a half minutes. So in terms of detail, how you can access them, so they're both publicly available now. One's shared on the Michigan website, so the link is posted here, and the other one is shared on the Open Neuro repository, and both are shared under a Creative Commons license, so you can use it as long as you attribute us. And if you want more details about the paper, so I'm going to go over a bit of it, but if you want definitely more details, you can check out our forthcoming paper, which is like LREC data paper, kind of going really into details about the data collection and how the scanning protocols and everything, if you're interested. So in terms of data collection, for EEG, we had 49 participants. And there were different analyses done, and like the paper kind of describes if in certain cases certain participants were excluded in case there was too much movement or they had like a really low score on a quiz, but they were recorded at 500 hertz from 61 active electrodes. And this data collection was done with John Brennan and his students at the University of Michigan. And for the fMRI, we had 26 participants, and it was a 3 Tesla scanner with a 32-channel head coil at Cornell University. And this was collected, so I and John Hale and some other students, we collected this data set while I was at Cornell. And the study design was the same. So the participants came in and, there was no explicit task. They just had to listen to the entirety of that audiobook. And once they heard that audio section, they all completed a multiple choice questionnaire at the end. And they all did fairly well. Some of the EEG participants didn't do as well, and that's also noted in the paper. So you can kind of take a look at if you think that, some people weren't paying attention. So that's also kind of given in that paper. And so along with the actual data set that we released, we also released the timestamp of every word in the story and also some of the predictors. So we already have some published analyses based on these data sets. So last year, John Brennan and John Hale had an EEG paper in PLOS One about hierarchical structure guides rapid linguistic predictions during naturalistic listening. So for this one, they basically found that it's hierarchical structure rather than sequential information. And all the predictors that they used for this, it has been released with the data set too, in case you're interested in replicating it or, trying to kind of extend that analysis further. Then another example of an existing analysis would be a brain and language paper from 2016 that, we had John Brennan, John Hale, and some other people on. And there they were trying to kind of look at how linguistically rich grammars were found to be correlated in temporal but not frontal regions. And all the predictors that were used in that analysis has also been released. So it's also available. And then one of our other colleagues, Jixing Li, did a study using the fMRI data set to test a predictor based on the distributional hypothesis, confirming a meaning-related role in the anterior temporal lobe. So this is just to give you a sense of kind of the space of research questions that's been asked, but there are definitely lots of kind of further questions you can ask and new hypotheses that you could test, because this data set is not task-based. So anything that you're interested in, you can go and test your new predictor based on that. Or a lot of the prior analyses have been done in SPM and MATLAB if you're interested in trying it out in a Python environment. So I know for EEG, there's like EELbrain, MNE, and for fMRI, there's NiLearn. So if you want to try it in like a different environment, replicate the analysis, that's also another possibility. So if anyone has any questions about the data set, or like if there's anything that's come up in the chat, I'd be happy to answer those.
Okay, so thank you, Shahini. That's great. If people have questions, like I said, please try to use the Google Doc. So again, I can send out that link here because I think some people have joined now. So I'm gonna just copy that link and put it into the chat. There you go.
Okay.
And so question, so this is both fMRI and EEG, right, Shahini?
Yeah. It's both, and it's so there were different participants, but they heard like the exact same stimuli at the same rate. So, so far we haven't done analysis kind of incorporating both the spatial and temporal information, but that's definitely a possibility too.
Okay, right. So for people that were getting started, that just wanted to do like a first pass at this. So this is all naturalistic comprehension, right? So these are like, it's a naturalistic kind of story. And this is very different, I think, from what many of us are used to doing, which is a controlled experiment.
Yes.
So can you just give some thoughts on like, how would you start approaching, doing that? Like, is it necessary to use the same kind of computational, parsing approach that you used?
No, I mean, you could definitely start with like a simplest thing would be, so for example, like the timestamp of every word is given. So if you want to just test something like noun versus verbs, right? You could just annotate them. You could have a binary like 0, 1 sort of a predictor, and just in a same, for example, an fMRI thing, if you just did a typical like GLM thing, and you wanted to kind of compare the effect of noun versus verbs, you could just annotate all the nouns with like a 1 and the verbs with a 1 to do like a contrast like that, which would be comparable to kind of more of the kind of classic kind of control-based designs. We did more like gradient predictors based off different kind of NLP stuff, but you can kind of start with like a very simple predictor and see, how that works out. And then you can maybe extend that to like further kind of like parsing metrics or like anything else that you're interested in.
Mm-hmm. Okay, I'm going to take a look at the Google Doc. And so one person is asking, let's see, are there metadata on participants' linguistic background? Are they monolingual, know a second language, etc.?
So I think I'm pretty sure it's for the EEG one too, but for the fMRI one, we made a note of when participants were bilingual, or like multilingual, but we didn't make a note of the exact languages they spoke. As long as they were self-reported native English speakers, they were included in the study. So I definitely know we had some like Korean English, Hindi English, like bilingual speakers. So we just kind of made a note that they spoke another language too.
Okay, so they're all native English speakers.
Yes.
And they possibly are bilingual. Is it noted that they're bilingual in the data set?
Yeah, In the metadata. So yeah, if you go to the repository, there is a README file with the metadata for describing all the participants, including, I think even, so we did a little audio check to make sure like they could understand the story properly. And so even the decibel at which the story was played was kind of similar across all participants, but the exact decibel level is also noted for all the participants. We didn't use that value in our study or their quiz comprehension results, but how well they did on the quiz, what kind of volume the story was played at, those are all noted in the metadata.
Okay, that's fantastic. Okay, so that behavioral data could all be used to incorporate. So that's great. One person asked a question, is the audio that participants listen to also available, like the stimulus?
Yes, so we included with the data set, but we also sent, it's the link from, it's, what is it called? Library Box, which has like tons of audiobook. So it's actually a free download. So if you go to that website, you can also download it directly from that website. But we also include the link in our repository.
Okay, that's
so you can definitely get the audiobook for free.
That's great. If anyone has more questions, if you're just tuning in, please go to that Google Doc that I just sent a link to. And you can add your questions there. So can you, so maybe you can just talk for a minute about what you've done already, like some of the results that you guys have done with this data set.
Sure. So I gave a couple of examples here. I'm trying to think of some other stuff that people have done.
So you presented actually at CUNY, right? It was your poster, and so
yes.
You know that so that second paper you listed there, that's the fMRI paper, and you used that same data set. And then what you did is you added regressors based on properties of the verbs based on selectional restrictions, right?
So, William, that's actually a different data set. So I collected the data set as part of my dissertation. So that's based on Little Prince English version. So that's not publicly available yet.
That's right.
This is a study I was involved in before this Alice in Wonderland one. That one we're hoping to release it in the future because that's actually a cross-linguistic work because we collected the English data set. Jixing Li, who's listed on the screen, she collected the Mandarin version of the Little Prince. So she has fMRI data for that. And currently in France, there's a group collecting the French data for the Little Prince. So the goal was to do a cross-linguistic fMRI study. We haven't kind of finished scanning, so we haven't released that data set. Down the road, that's a goal, down the road to kind of release it. And that'd be like a kind of cross-linguistic parallel fMRI data set. That's not out there yet. But yeah, my recent work has been based on similar. So that was actually longer because that's 1.5 hours. That's a longer data set, similar naturalistic stimuli, and a lot of my recent work on argument structure, looking at non-compositional expressions, kind of has used that data set. And right now I'm looking at things like topical surprisal and how to incorporate kind of contextual information. But yeah, like that's the thing. I mean, I've been using that same data set now for like, I think over 2 years to answer all sorts of questions. So this kind of naturalistic stimulus definitely kind of lends itself to that kind of flexibility.
That's great. Okay, we got a couple more questions here. So one person is asking, is the code used for the NLP models also available if they want to implement the analysis in a different pipeline?
So the predictors are available. The way we kind of derive the predictors, like that kind of code isn't available. But if you kind of reach out to me or John, we can probably help you out with that. But for example, for the brain and language paper, they calculated like bigram, trigram, surprisal, and all of those values for each word, it's already available. So if you just want to replicate it, but in a different pipeline, you can just run it. We have it all in a spreadsheet. So that's available. If you want to know specifically how we did it, you can, it's described in the paper, but you can also reach out to me or John. We'd be happy to kind of help out, answer any questions.
Okay, that's great. And then there's another question here, which is, as far as I remember, the audio was slowed down, so it may not match what was in the audiobook from LibriVox. Is that correct?
Yes, it was slowed down by 20%. So I think we have the slowed down version included, but we just slowed it down in like prod. So we didn't do anything like super fancy with slowing it down. So it was just done in prod. So you could download and do it yourself, or the slowed down version is included too.
Okay, that's fantastic. So I just want to let everyone know it's great. Add questions. If you wouldn't mind adding your name, that's helpful as well. If you feel comfortable with that, because when this is sort of a rushed session here, but if there was more time, we can actually, click on you, unmute you, so you can ask your question yourself and any kind of follow-ups or clarifications. If anyone else has questions, please post them right now on the Google Doc. If not, then we're gonna transition to the Finding Five tutorial.
Yeah, and people can definitely reach out to me. You can also the data paper that I mentioned. It's in the schedule that William sent out, the link to it, and also it's on my website. So if you want to read the data paper, it has links to all the data sets and like it describes all the data sets too. So, and also you can email me. It's just shahini@umd.edu, and I'll leave my contact information on the Google Doc if people have questions after this.
Okay, that's fantastic. Thank you so much, Shahini, for doing this at the last minute. That's really helpful. Just want to let everyone know that in the afternoon, we're going to have a presentation by Joshua, and he is going to talk about just generally different databases that are online, publicly available neuroimaging databases, and his experiences accessing and using those. I'm sure that one of the biggest issues with these publicly available data sets is trying to understand what people did, exactly how they did it, and how to find things that are actually of interest to you that are usable for the questions you want to answer. So that will be covered in the afternoon.